Okay, there we go. Perfect. So welcome to July and summer, and here we start. Hello and welcome to members. We hope you're enjoying this amazing summer, and thank you for joining us in this meeting. Star party. So as our wonderful Madam Mayor Madam President just said, we have our first one finally, guys. So we hope to see you all there at the end of this month, July 30th, Saturday. And ANSA, bring your energy, bring your sanitizer, bring your mask, whatever you want to bring. More meetings that are coming up. They're all in the calendar. As you can see, astrophysics, it's July 15th. Beginners class, it's August 5th. And OCA meeting is coming up this month. So if you want to consult and come there, more meetings will be also in the calendar for your review. Okay. How we are being able to resume our monthly ANSA Star parties, the Star Barbecue. Thank you. Look forward to seeing you all there. Mount Wilson is doing a summer retreat. We had the party last week as well, last month. It's July 7th to the 30th. If you're interested, please go to that site for the application. Also, we are currently looking for ground volunteers for the upcoming outreach events. If you're interested in any way, oh, whoops. If you're interested in any way, please contact Cecilia Caballero. Galileo.
Hello, my name is Galileo, and today is going to be a waxing giveaway. Hopefully you guys see the beautiful moon tonight and have a good day. Good night.
Thank you, sir. Okay, the adopted program, the perks of being a member, OCA, is that you don't have to buy a telescope by the time you could adopt one, see how it works out for you. Hopefully you love it, you keep it. If not, you come and return it. It's on our website, resources, scope, and download the agreement and look at the inventory for your review. So for the serious astronomer, we're looking always for new content. So if you have amazing pictures or any discoveries or something that you want to share with the club, please do so and submit your piece and your photos for review to the editor, Dave Fisher, at newsletterastronomers.org. About the newsletter, if you want to save some trees and you want to stop receiving it hard copy, please inform Charlie. That way you only get it digitally. And then if it is digital only, you get to see it in color. And you save a few trees there for you and you get to like not have a clutter of paper in your house anymore. If you're interested in that, stop receiving the actual paper copy. Charlie will be the guide to go to. Reminders, even though we don't go as often, we still, when you do get up there, please take care of the area, clean it up, door closed. If you have food, take the food out of the refrigerator. And if there's weeds, even though they're not your weeds or they're not in your area, if you can please be kind and take care of that for us as a team that we are, that would be really lovely. Thank you, guys. And then stay tuned for the main presentation. We have actually our WhatsApp. And the next meeting for youth calendar is August 12th. So we'll see you then, guys. Hope you had a good time. And I did want to say thank you to all of you that went to the OVRO trip 2 weeks ago. It was lovely. We had so many OCA people there, and it made it really wonderful. The students are still really happy all getting to meet so many of us there. And thank you for your time, guys. And now, am I?
John, now it's your presentation. Yes.
Okay, so now, without further ado, our own and wonderful Mr. Garrett on the screen. Bravo!
There. Thank you for making noise while I was figuring out how to unmute myself. Thanks for having me do the What's Up. It always inspires me to get outside and do some observing. In this case, it inspired me mostly to work for my backyard. I didn't get out to a dark location, but that's mainly because by the time you have to get out to one, it takes a couple hour drive from my location, and you need to be set up about like 9 o'clock in the evening. Well, anyway, by the time you've done a couple hours of observing starting at 9 o'clock in the evening, coming back late is just really a late. This is because this is the shortest nights are right now. So that's why I didn't get out in the dark locations, but I did see a lot of stuff from my backyard. This photo that I'm showing you right here is one I took at Joshua Tree a few years ago, and it depicts right now where the view toward the north is. And so if you at about 9 o'clock this night, if you're starting to set up your telescope, you'll notice the Big Dipper in that position. And here's a bunch of the star names. And Little Dipper will be, the Big Dipper, of course, is Ursa Major. And the blue stars I've outlined are the stars that give the constellation its actual name of the Big Bear. And so you can see the shape of a bear there. And this time of year in the early evening, the bear gets to walk on ground again. So it's rotating with the bear putting his feet down to the ground. And then the Little Bear is up in the air. And between these two, we have Draco the dragon. And sorry, I'm having a little delays. All right, Canis venatici is right here above the bear. And Coma Berenices is all right next to it. And then if you look down way below, Leo Minor, a constellation that you might never have looked at, is setting in the west. And if you look in the sky, you'll find that there's a number of nice deep sky objects to our north and northwest still worth looking at. And some of the favorites are, of course, M101, a galaxy that we see edge on. I haven't been able to see this from the city, but once you get into a dark location, you can see it, and it does photograph pretty well from the city. And I photographed this one, by the way, from the city. And it's still pretty high, very good to see. M97 and 98 are starting to get pretty low. So if you wanted to see them or get a picture of them, now's the time. Otherwise, you'll have to wait till much later in the year. And then another favorite, M51, also a very faint object for trying to look at and nearly impossible to see in the city. But at a dark location, it shows up nice and it photographs nice, even from the city. And then one of my favorites right now this time of year, the globular cluster M3 is very high. So you follow the dipper's handle, and that puts you up from the handle right here up to M3. And also the North Galactic Pole is here, which isn't like an object that you can look at, but I'm just going to have you contemplate something. If you see this arrow, I'm drawing a line between the Little Dipper's pole through the handle of the Big Dipper toward the North Galactic Pole. So that gives you an idea about where the North Galactic Pole is. Now we're going to look over at another group of constellations that I took another summer when I got out to a dark location, actually Palomar Observatory Campground. And here is the two dippers. And this image is a very wide field exposure. I think it's like a 12mm lens that I borrowed. And so the constellations are a little distorted and the whole view is a little distorted. But you can see with this arrow about where the North Galactic Pole should be. So it'll be in that direction, extended a little higher above this view of the Milky Way. And so this is an opportunity right now to appreciate some of the greatest scale geometry that I think the human can actually perceive. You can look at our galaxy in one direction and imagine that you are on this disk, and then you crane your head either looking backwards or turning around and looking backwards to the direction of the North Galactic Pole, and that's where this center of this galaxy should be pointing. So it's an opportunity to look at that and just think, wow, appreciate that the distances involved. And also in this field of view, there is a dragon, Draco the dragon, and next to Draco is the constellations Lyra and Hercules and the Corona Borealis. And going a little farther south, we see the spectacular Milky Way rising and the constellations in it. And there's just no way I could cover how many things you can see in that area, but it's a good subject for August and September too. And over there in the far south, you'll see the Archer, Sagittarius, and Scorpius, the Scorpion. And in this big blank area is the large constellation Ophiuchus, the serpent bearer. And I've drawn the serpent because serpents are easy to draw. And the Ophiuchus, the serpent bearer, is something like that, and I haven't actually drawn him. But in the middle of Ophiuchus is a comet. And I've been tracking the comet. It's pretty faint. I haven't been able to see it visually from the city, but it does show up pretty nicely in photography. And so I'm just having just quite a little bit of a dilemma here because I have my screen, my control screen is blocking my menu options. But a quick look over at the constellation Boötes or Boötes. I almost wanted to skip it because I don't want to have to try to pronounce it. If it looks like it's kind of bright on the top of this constellation picture, it's because I took the photo in May, and by now I can rotate the photo upside down and it works just fine for showing you what's in the west. And so here's the constellation of Boötes. And over there in the bottom corner is the end of the Big Dipper's handle. And so imagine coming off that handle, following the arc to Arcturus, and gives you another view of Canis Venatici and Coma Berenices and Virgo off to the side, and Hercules and Corona Borealis and the serpents above. And then the deep sky objects you can find from this location here. You can see M51, which I've shown you already, M3 right there. But what got my interest in this particular area, I was photographing NGC 5053 and M53, and I didn't realize how close they were together. And when I took my picture of M53, I didn't see any other objects in the field of view. But when I panned over to NGC 5053, I saw that M53 was off to the edge. So one of my goals before the sky moves on a little farther and sets more is to try to get a photo of these two where I better framed the two together. So that's something you might want to look at too. Also, one of the things I love finding, and there's quite a few showing up, is planetary nebula. And what I like about these is that you can just take a small telescope, point them in the area, and then look at your camera, and every now and then a certain star will just pop out as just really green, and that's your planetary nebula. And so here's the planetary nebula 6058 showing up in my small 3-inch refractor. And here it is in my 8-inch Schmidt-Cassegrain, and there you can actually see just a little bit of the fuzz around the center of the planetary nebula. So if you're an imager and haven't imaged this one, I'd recommend giving it a good look. So those are some of the things there. Going over to the other side of the sky, directly above us, is Hercules. And I can never find Hercules when I look for it from a dark sky. I often find a triangle first that is like the head of Draco the dragon. And then that's usually the foot of Hercules. And so here's the constellation Hercules and a few of the star names. And here's my interpretation of a more modern version of Hercules, the strong man. And there's some planetary nebula and other objects in Hercules, most notably the globular clusters. So this is definitely globular cluster in Hercules season because they're directly overhead as the sky gets dark. And of course, a common favorite is M13 that shows up well in the city, and especially well in a dark location, and is easy to photograph. I photographed this one just a couple nights ago with my 3-inch telescope. And also with the 3-inch telescope, I photographed M92. I didn't preserve the scale and size between these two drawings. I didn't have enough time to double check my work, but M92 is definitely smaller, but it also shows up pretty nice. And then the smallest one of the area is NGC 6229. And I haven't been able to see that from the city in my 8-inch scope, but I'm confident it would show up in a dark location. And then also, some more planetary nebula, NGC 6210 shows up as a very bright green dot. And also 6058, there's two versions of that, which I've shown you with the other slide. And then also an IC catalog number, IC 4593, also is very bright, kind of surprisingly bright. So I mentioned that there's a comet in the sky. Last night, I set up my 3-inch scope at focal ratio of f5, which I'm using a focal reducer. And so this was under moonlight, and you can see the comet right here. And give you an idea of scale, here's a picture I also took with the same equipment of the moon. So that gives you an idea of how big the comet is in the sky compared to the moon. And I haven't been able to see this through a telescope yet. And I admit that part of the reason is that my aim was a little bad. I was a little off. And so my telescope, my 8-inch scope is pointing here and my small scope is here. And it wasn't until I got to looking at the picture later, I figured out one of the reasons that I wasn't able to see the comet, but you probably won't find it in binoculars. Yeah, I think I would recommend going to a site such as the Sky Live and scrolling down to their finding the comet name by C 2017 K2, and they have an ephemeris publishing of its coordinates and use that to find the location. So that's where I've been going to find comets. Okay, so I have a friend in England who does a lot better work than I do with this photography. I'm more of a 1-minute astro imager, and my friend was willing to take, spend 90 minutes on just a comet, and he comes up with something like this. So that comet that I showed you that wasn't very impressive to see in my photographs is probably worth it if you've got a nice setup and ready to do some long-term exposures of it. So he took this picture on the 29th. Supposedly, it's going to be getting closer. I think the 14th of this month is its closest time. However, that also coincides with the growing brightness of the moon. But after the full moon has passed, you may get some early evening shots of it without the glare of the moon. And there are meteor showers to watch out for, or to have the opportunity to look for. There's the Southern Delta Aquariids. They're supposed to peak on July 30th. Hopefully 25 per hour with a favorable moon. So it will be a dark night. And so that I think makes it very worthwhile to choose that night to go out and set up a camera, a wide field camera anyway, and see what kind of images you get. Oh yes, also the Perseids. The Perseids technically start as early as July 17th, but their peak is August 12th, which is actually the date of the next OCA meeting, but that's also the date of the next full moon. So I'm not terribly optimistic about photography on that, but I think you will if you go out, if you skip the meeting or get out afterwards, you might be able to see some stuff of the Perseids. But the Southern Delta Aquariids are going to be here in the constellation Aquarius. And so this will be up midways in the south, in the middle of the night. And you'll also see Saturn and Jupiter in the picture, but the radiant isn't going to be very far from the planet Saturn. And so the radiant is about there. And perhaps my radiant drawing is over optimistic as to how many meteors you might actually see, but it's worth a try. Last month, actually the end of May, there was this aberrant meteor storm, this possible meteor storm, I forget what it was called. And it wasn't a very good night for observing. It was very hazy where I was in the city, but I put my camera straight up at the sky at the radiant, and I was able to capture multiple meteors from that event. And so this is a composite of images of the same area. So there was no problem in just overlaying the images and then cutting out the meteor parts, but this is what I was able to get of the radiant. So if the Aquarius one, you might want to just point your camera right here, include the irradiant and above the radiant, and sit there and maybe you'll catch some meteors. And again, with meteors, always do a super saturation of the image to see if you can bring out the color so you can help confirm that they're actually a burning object and not a reflective object, such as a satellite. Many satellites actually brighten and then dim, and then they brighten and dim and brighten and dim, but it's very common to capture just part of that cycle and think you've got a meteor. So I always like to see if I can get some color to confirm that they're a meteor. So those are some things that are up in the sky. Recommend getting out, enjoying it. And the only thing that's bad about this time of year is that the nights are so short. Thank you.
Thank you, John, for yet another great What's Up. Hi, my name is Reza, and I'm the Vice President of the club. I, too, would like to welcome you to the July 8th, 2022 General Meeting of the Orange County Astronomers. Our speaker at this meeting is a research curator in volcanology and space sciences at the New Mexico Museum of Natural History and Science. He's a member of the Perseverance rover science team, where he's responsible for geologic context mapping of the terrain traversed by the rover. Previously, he was a team member on many other Mars missions. His specialty is field geologic mapping of young volcanic terrains, but he has a long research career in planetary geology. He always likes to say, Mars is like New Mexico, just more so. So Mars is a natural place for him. Please join me in welcoming Dr. Larry Crumpler. Larry. Okay, let me help you unmute.
Sorry, I knew I would forget to hit the unmute button. So thank you for having me, and I hope to just show you a little bit about the history of Mars exploration tonight. I have a few slides to get through, so maybe I should just go ahead and get started with the presentation. Can you see the presentation?
Yes, perfect. Thank you.
Okay, great. Okay, so the title of this presentation is slightly changed from what it is on the program. I'm calling it Exploring a New World, 21st Century Natural History Exploration of Another Planet. And that's essentially what we've been doing with Mars, with the rovers over the past 2 decades now. Basically arriving at a place, trackless wilderness, a place that has not been examined by humans before in history, and we're basically learning about the terrain, learning about the landscape, driving over it and learning things that were beyond your wildest imagination before we got there. So it's really exploring a new world, pretty much like we explored new worlds here on the Earth. When we first arrived at the continent, it was totally unknown. We basically tracked into the middle of the continent on many expeditions and many pioneering expeditions, and learned what was there, and learned to ask new questions and become increasingly familiar with what was there and what questions were really the important ones to ask. And that's basically what we're doing in this case with a real new world, which is Mars. So what I'm going to do is talk a little bit about the history of our how we got to where we are now with understanding the surface of Mars. And this view over on the right is one that got me to thinking about something very fundamental about where we are in our understanding of Mars. This image was taken by the Mars exploration rover Spirit early in 2004 as we were driving across the floor of Gusev crater where the rover had landed previously on January of 2004. And we did this, this early morning pre-dawn image of the eastern sky. And there hanging in the sky was this bright dot, bright star. And that star was Earth. And that basically was an interesting point in time, because at that point, we were doing precisely from Mars what we had done for centuries from Earth. Over on the left, viewing Mars, we always saw it as just this bright dot, an orangey red dot in the night sky. And for many centuries, we always, once we knew that this was an actual planet, we wondered what that dot was like, what it would be like to be there. And then here in 2004, we were actually on the surface. And so we had the opportunity to satisfy those questions we had asked for all those centuries. So our understanding of Mars really got started with the early telescopic observations shortly after the telescope was really invented. And Huygens, as a matter of fact, in 1659 did some sketches of Mars, and he noticed that there were dark features on the surface that seemed to be affixed to the surface. And so using that, he was able to do an early estimate of the rotation rate of the planet. And lo and behold, he came up with a number of 24 hours and 40 minutes just on the basis of these faint dark markings that he could see in his telescope. And that turns out to be just a shade over a minute longer than the actual time that we know today for the rotation rate of Mars. A Mars day being 24 hours and 39 minutes, which we call a sol to distinguish it from an Earth day, because it's very important when you're on the planet to know which day you're talking about, a day on Earth or a day on Mars. So, and then of course, with other observers over time observed the polar caps like Herschel did in 1784. And so we got the impression that it was a place that actually had some sort of weather, some sort of climate. And over time, there was increasingly array of more detailed observations of the planet. For instance, the first true global map of Mars was done by Beer and Modler in 1830. And they captured most of the prominent dark markings that we're familiar with on Mars from later observations. And subsequent observations over the rest of the 19th century pretty much improved on those observations with increasing detail, some with more elaboration than others, like Lowell's observations, and sort of culminated in the early 20th century with Antoniotti's map of Mars that he did, in which he basically saw many of the things that Schiaparelli and Lowell saw, but he was a more astute observer, perhaps, or perhaps less imaginative, so his observations were a little bit more with the reality that we know of the dark markings on Mars. And basically, that map lasted all the way through to just a few years before the advent of the first planetary spacecraft missions to Mars, with the publication of the U.S. Air Force, who was tasked with providing charts for preparation for the exploration of Mars with upcoming missions in 1962. Essentially, it's Antoniotti's map with all of the classical Mars names applied to it. But there's kind of an interesting thing about Mars that I've noticed over the years, and it's appeared repeatedly in our observations and our explorations, and that is that the Mars kind of likes to play tricks on us. It throws something in our path that we think is interesting, and so we start really investigating that, like dark markings on the surface of Mars. And then later on, it reveals to us that that actually had nothing to do with anything, and that there are actually more interesting things we should have been paying attention to. And so that happened to us with the later spacecraft missions to Mars, where we finally got global images. For instance, with the first orbiter, Mariner 9 in 71, we revealed that those dark markings really had very little to do with the actual physical surface of Mars, other than just being essentially paint on the surface. And that the actual planet had a lot of interesting diversity in terms of its terrain types and geological features, large volcanoes, canyons, large impact basins, and in many places we could see dune fields and ancient river channels. And then with subsequent missions like Viking, that resolution increased, and we actually began to learn and ask detailed geological questions about the history of the planet, how these features formed and when they formed. And then, of course, our modern view over here on the right is the Mars Global Surveyor Mars Orbiter Laser Altimeter view, with which we actually got detailed relief or topography measurements of the planet. And so that's how we view Mars today in this color-coded relief version. And it turns out, of course, that the dark markings, so prominent in all of our questions during the early telescopic phase of observations right up through the middle of the 20th century, had nothing to do with the actual interesting physical planet. They were simply dark areas where a lot of the dust was blown away, there were more rocks, and then the bright areas where there was more dust. And so the actual planet is considerably more interesting and considerably more varied in its terrain type. So this is our view of Mars now. And so this is the sort of the global view of both hemispheres in all its glory. And of course, you can see lots of details here. You can see that there are, first of all, two hemispheres of Mars. There's a northern hemisphere that is fairly low, blues are low, a southern hemisphere that is fairly high, reds and yellows are high. And that southern hemisphere appears to be somewhat older. And the reason I say that is it has more impact craters. So it's collected more impact craters than this northern low area of Mars. So right away we know that this is an old area, this must be something younger. And then of course we have volcanoes superimposed on that, like the Great Olympus Mons volcano, which is the size of many of the Four Corners states. So we're talking 500 kilometers across here. The other volcanoes, Fast Valles Marineris, named after the Mariner 9 spacecraft, which first discovered it in 1971. And then, of course, a series of outflow channels and other relief features. So that's kind of where we were, or where we are now with the general global relief of Mars. And now I want to talk a little bit about some of the exciting steps along the way in the process. So what you're looking at here is a chart that starts with 1960 on the left and goes all the way to about 2030 on the right. And I've placed on it the individual successful and partially successful Mars missions over time. And of course, our first successful Mars mission was a mission in 1965 called Mariner 4. And perhaps some of you, like me, were sitting by the radio in 1965 waiting to hear the results of that first flyby. And of course, we were all greatly disappointed because although we no longer had this fuzzy telescopic view and we now had pictures up close, the pictures showed a place that looked very cratered and very devoid of anything exciting to really learn about. And of course, that was just an unfortunate characteristic of the flyby type imaging, as we'll see in a second. But as time progressed, we sent more sophisticated missions. So the Mariner 9 spacecraft, global first orbiting spacecraft, got global images, and that's where we learned that Mars is really a dynamic place, has lots of exciting geologic features. And then, of course, subsequently with the Viking orbiters in the mid-70s, we had higher resolution still, and we learned even more questions to ask, as well as learning more about the actual physical and geologic characteristics and atmospheric character of surface. And then there was a long period of 20 years of no Mars missions for various political reasons, with one exception of a Russian mission that was only partially successful, Phobos 2, but it didn't really contribute much more than what we had learned with the Viking spacecraft. And so our exploration of Mars really picked up again in the late 1990s with the beginning of a whole armada of spacecraft that we've subsequently sent to the planet, in which we've learned that it's a very exciting planet. This is a very high resolution image taken by the Mars Reconnaissance Orbiter showing sedimentary layers on the surface of Mars. And this camera is essentially an air photo type camera, and that we can see features down to 0.5 meter in scale. And then even beyond that, we've moved on to actually sending rovers that roll over the surface of Mars and give us the sort of view that you would have if you were standing there. And then after that, we move into a period that I call the age of investigations, where we've already done this sort of gross exploration of the surface. We kind of know what's there. We know the general terrain. And now we have questions in mind, and we went to a variety of places to answer some of those questions. So let's start with a couple of those missions. So the Mariner 4, of course, was flyby, and here we've got in the background our modern map of Mars. Of course, at the time, all we had were telescopic images that we could overlay our footprint of where the images were taken on the surface. And this is what it looked like. It marched across the surface during the flyby. It took about 20 good, relatively useful images. But it turns out that most of the images, the early images, were fairly fuzzy, very difficult to see. And then when we finally got with more or less a vertical perspective where the images were fairly clear and fairly high resolution, we were positioned over what, as it turned out, were in fact the cratered highlands of Mars. So our images looked basically like the moon. And so as luck would have it, we arrived just a few minutes too late to see interesting things and a few minutes too early to see interesting things like enormous Elysium Mons and Apollinaris Patera volcanoes or river channels and other features. Always saw these cratered features. Then in late 69, we sent Mariner 6 and 7, which also were flyby missions, and their results were not much better. The images that were over places where there were some interesting things that actually flew over and covered the Valles Marineris system were somewhat fuzzy and difficult to interpret unless you actually knew those features were there. You wouldn't see that. But boy, we could see lots of impact craters again. So the impression at that point was that Mars was, probably a cold, dead planet, probably pretty much like the moon. It's just that it had a little atmosphere doing some interesting things like polar caps. And in any case, at that point, of course, we were sending humans to the moon, so the whole Mars exploration program kind of became sort of secondary. But then things totally changed in 1971 when we sent Mariner 9 in orbit, the first orbital spacecraft around Mars. And it did global imaging, ultimately, of the surface of Mars. But lo and behold, Mars pulled another trick on us. Mars is always throwing obstacles in our way just to tease us. I like to think of Mars as being somewhat like the coyote or the trickster of indigenous American legend, in which Coyote is portrayed as a character who basically teases you and causes you trouble. But as a Native American friend of mine explained it, it's not just a troublemaker, but it's more like a grandfatherly troublemaker trying to teach grandchildren a lesson. And the object is to tease them to the extent that they have to dig a little bit deeper to get the real answer that they're looking for. And so I came to think of Mars as being kind of like Coyote. And the idea of Coyote Mars came to mind. So repeatedly in our exploration, Coyote Mars throws these little tasks in front of us to keep us from getting where we want to go. And so we have to dig a little bit deeper. And sure enough, when we arrived with Mariner 9, there was a global dust storm that had just started. And so the planet was just an opaque ball of dust. But lo and behold, as the dust started settling, we started seeing these large dark spots emerging from the dust. Apparently, they were tops of enormous mountains, and the tops of each of these mountains had craters on them. And so it became clear right away that we were looking at enormous volcanoes on the surface of Mars, and that Mars was not, in fact, dead like the moon, but it actually had some geologically interesting things going on. And of course, later on, we learned that there were other things going on the surface, like these canyons, Valles Marineris and river valleys and so on. And of course, also during this period, we had a Russian spacecraft that was going to Mars during the same Martian opportunity. And it basically arrived at the same time. And it was a lander. And so it was forced to go into the surface during the global dust storm. And apparently it actually successfully landed on the surface, but it only operated for a few seconds, sending back an image, which is anybody's guess as to what it's actually showing. But it did transmit a few seconds from the surface before going silent. But Mariner 9 went on to basically be our first global view of the red planet. Then, after that, in mid-70s, we sent the Viking spacecraft, 2 orbiters and 2 landers, for the first successful landings on Mars. And this is an image of us sitting around the table in the Viking orbiter imaging room there in 1976. In those days, imaging teams for spacecraft were, a fairly small group of people that you could fit around the table. These days, you would have trouble fitting all of the participants into an auditorium. And so we were tasked with, learning about Mars, exploring it, basically like the first explorers in a new world. But before we got underway with that, we had to get 2 landers down onto the surface. And I was involved in the process of looking for the landing site for Viking 2 lander. All we had to go on at the time were these early mosaics from Mariner 9, which was somewhat grainy and low resolution. And in any case, so I picked this place after a long and careful study. And we had many meetings, but we had to get the spacecraft landed on the surface of Mars. And so it was our first experience with picking a landing site on another planet. Here's a view of the size of one of the orbiters. There's my wife, Jane, working on some of the early mosaics, analyzing, probably doing crater counts of some of the early mosaics on the surface of Mars. Anyway, Viking was, as I said, a really first detailed global view in which we were able to actually parse some of the geologic details and ultimately do global geologic mapping, and in fact, regional and high resolution mapping. And what we geologists do that for is to actually understand the sequence of events that lead to the development of terrains. And in this case, we learned that there's a lot of different types of rocks and terrains on Mars, and they all have overlapping relationships that we can use to tell which one came first and which ones after that. And then we have crater counts that we can use to estimate ages. And so during this long, dark period of no new Mars missions, we spent a lot of time picking the Viking data apart and coming up with these incredibly detailed studies and understanding of the surface of Mars. This is where we basically learned what Mars was about. And so over on the right is a geologic time scale for Mars compared with the geologic time scale for Earth. And on Mars, we divide the time into basically 3 intervals, a very old era, about 3.5 billion years ago in the Noachian. That's all of these highland cratered areas in brown. An intermediate time area when there was a lot of volcanism, and it covered vast areas of the surface of the planet. And there was also a series of outflow channels apparently from fluvial events and early tectonic features or faulting or Mars quakes. And then a later period called the Amazonian, which is essentially the Mars surface that we see today. And it includes all of the things that have happened after most of the major events took place. Although there have been a number of large volcanoes that have continued to erupt through that time and may even still be active today. And so anyway, this is our picture of Mars after an extensive period of really trying to understand it over those long years of what I call the lost generation. And many of us were starting our careers, and basically all we had to work with was the Viking data. So anyway, most of what you know about the Earth is in this period called the Phanerozoic, the last 600 million years, which is like a very small slice of the most recent geological time on Mars. So Mars is a very ancient and old surface. So then moving forward, we come to the transition to the age of investigation, where we had learned all about the surface of Mars, and we now wanted to ask detailed questions that helped us understand what it was we were seeing. And with that, we started sending spacecraft around 2000. We sent the Mars Odyssey spacecraft, which was tasked with getting a global chemical map of Mars. In 2004, we sent 2 rovers to the surface of Mars, the Mars Exploration Rovers, where we actually did our first true geological field mapping and walking across the surface of the planet. And understanding Mars as a physical, real place. Also in the early 2000s, we sent the Mars Reconnaissance Orbiter. That's the one with the high resolution camera that's just still operating today, which we have views that are essentially, you could see something the scale of your backyard, or the lawn chair is actually in your backyard with the Mars Reconnaissance Orbiter, and that has spawned a whole new field of understanding the details of the surface. And then later in the decade, of course, we moved to some of the current missions, which we're all familiar with, and we'll go into in a minute. But the Mars exploration rovers were quite exciting because they're still one of my favorite missions, because with that, you're down on the ground at human scale, learning about things, about a new world that you really hadn't really seen before, and learning about it not only in just one place, but in many places and over many, many years, so that we came to feel like we were actually living on Mars. In fact, during part of the time, many of us were living on Mars time, and so we had special watches that were designed to operate on the Mars cycle, the Mars day, the Mars sol, as we call it, of 24 hours and 39 minutes. Of course, working on the mission, then interacting with the Earth time was kind of a challenge, but nonetheless, that's what we did in order to keep track of the uplinks and downlinks, and to follow all the things that were happening on Mars every day. We were learning how to operate rovers on the surface of Mars. We learned all about some of the physical characteristics of the environment, like enormous dust devils, very similar to the ones we see here on the Earth. We also lived through a couple of global dust storms, like the one that Mariner 9 encountered when it went into orbit around Mars. They happen about every 10 years. And during that time, the dust increases so much that the optical depth of the atmosphere it becomes very, very low, so that the density of dust starts to block out the actual sunlight, which is a bad thing for solar-powered rovers, which is what these were. Nonetheless, we survived one, but Opportunity did not survive the second. The other thing interesting about the environment of Mars was that we started seeing, not only over different times and seasons, but also different times of day. Every lander has taken images of the sunset, and of course the sunsets on Mars are kind of interesting because on Earth our skies are blue, and at night on the horizon the skies turn red. On Mars it's quite the opposite. The skies are red during the day, and on the horizon at night the skies turn blue. At night, we were able to do observations of things like the Phobos eclipses by the shadow of Mars, the track of Phobos and Deimos across the surface of Mars at night. We even saw meteors in the night sky on many occasions during nighttime hilltop observatory observing with one of the rovers, Spirit. And of course, the environment itself was interesting because of the clarity of the atmosphere. At the end of the day, we frequently ended up taking shadow selfies as the sun set behind us, much like you would see here on the Earth at the end of the day, on a nice clear day when you're in the field. And of course, all of this was about investigating the details of the Mars geologic past in an effort to understand whether it ever had conditions conducive to early life. And of course, we examined the rocks to do that because the rocks record what happened when they were formed. And you can basically travel back in time that way to understand ancient environments. And we saw many things, things like these gypsum veins, which form when water courses through cracks in rocks, and mineralized waters basically deposit the gypsum and crystals grow in the crack as the crack opens. And that was something new. The idea that you could have so much water on Mars that you could actually form features like that was interesting. The thing I did was that as we drove along, 20 meters on either side of the rover, I was able to use the rover imaging to actually keep track of the local geology, mapping the different rock types as displayed in the different types of colors here. And that was essentially the first field geologic mapping on the surface of another planet. Unlike the mapping we do on the Earth, where we do a nice big square quadrangle, here on Mars we were confined to mapping just along our traverse, but nonetheless it was the first characteristics that we were able to actually pin down with our individual observations as we drove along with the rover. Another interesting thing about the environment of Mars that you don't often hear talked about is the lighting. Of course, the intensity of the sun at Mars is about half that of the Earth. And so it turns out that here's an image on the right that was taken from a hilltop in eastern Oregon. And this was during the great North American eclipse a few years ago. It turns out that about 20 minutes before totality, the lighting from the eclipsed sun is approximately the same lighting as you would see on the surface of Mars. So that's what you're looking at over here, the same scene under Mars illumination. And you can see that it's not totally dark, it's not really dim, but it's actually, definitely a shade darker than a typical brightly full sunlit day. But there's another characteristic of the Martian terrain that's useful to consider. The Martian sky is not blue like that on the Earth. The Earth's sky imparts a bluish-white glow to the surface on a clear day, so that everything's illuminated with a fairly white light. But on Mars, the sky is red, so that things are basically bathed in a dusty orange-red light. So in addition to the lower lighting, the surface is actually slightly shaded or illuminated in a cast of red, kind of like a very dark tungsten light for that matter. So that's why some of the images you see of Mars always look a little unreal, a little different, because the lighting is actually very different from what you would see on a bright sunny day here on the Earth. The other thing that's interesting about Mars that we learned on the Mars exploration rover missions was the fact that the rocks are in many ways similar to the rocks on the Earth. Here we're on the left, we're looking at a rock that's typical of a Martian rock, very, very much coated in dust. And Spirit had a device on it that could brush dust off the rocks before grinding into it. And when we brushed the dust off, the underlying rock was actually exposed as being very, very glossy. It's almost like it had a varnish on it. And when we would grind through that with our grinder, it turns out that varnish was only a few microns thick, and that varnish was actually consisted a lot of sulfates. So that brought to mind, to me, the desert varnish that we're familiar with here on the Earth in desert areas, where basically something similar is happening. The rock is coated at a depth of a couple of microns with a dark material that is essentially just multiple layers of dust that have been painted onto the surface by being wetted by rains and baked in by the sun. And over a course of hundreds or thousands of years, you end up with a nice, in some cases, quite glossy coating on the surface of the rock. And then, of course, early indigenous Americans were able to chip through that and expose the brighter rock underneath. That's how petroglyphs are formed. So Mars has something similar. It's just that instead of the desert varnish that we know on Earth, which consists mostly of silicate minerals and clay minerals, on Mars it consists of what is most common on the Martian environment, which are sulfate minerals for the most part. But otherwise, desert varnish. The other thing we've been able to do is, of course, we observe the sun constantly to characterize the opacity of the atmosphere. It was very important. But we were also capable of observing the eclipse of the sun by Phobos on several occasions. This is one that was taken more recently by Perseverance, showing in real time the traverse of Phobos across the sun. There's some beautiful sunspots in the background, which were visible from the Earth at that time, but they were in a different location, obviously. So anyway, that's the sort of astronomical observations. We've done many additional types of observations, but just a small sampling of some of the things that have been going on. So that was during the 2000s. And then in 2010, we sent to Curiosity, which is the large rover that landed in 2012. There was an orbiter, MAVEN, which was tasked with understanding the climate history and atmosphere of Mars. At the same time, the Indian Space Agency sent an orbiter to Mars, which was probably the cheapest spacecraft ever sent on an interplanetary mission. And it actually basically arrived and has been operating since and taking wonderful images of Mars, demonstrating the technical efficiency of their space program. The Europeans sent a spacecraft called the Trace Gas Orbiter in the mid-teens, and that was basically designed to look for trace gases like methane. Of course, early on we had observed the presence of methane emissions periodically on the surface of Mars, and so this was an effort to understand where they were, when they formed, and how often. But so far, basically, the Trace Gas Orbiter has seen very few events that could be positively identified, even though at the same time, Curiosity actually measured some methane during one day during one of its traverses. Then we've sent in 2018 the InSight lander, which was a U.S. mission to Mars finally with a seismometer, which has been something that's been missing from our understanding of the surface of Mars and the interior for the past several decades. And it's been wonderfully successful, in which we've actually learned a lot about the interior of Mars now. We know that it has a large core. We know that it has earthquakes or Mars quakes, and fairly substantial ones. More recently, of course, we observed one over magnitude 5. And in some of the interesting places on Mars, like some of the largest ones and the most frequent ones have been in an area of the most recent volcanism on Mars. So Mars is still active, and we suspect both from crater counts and other observations that it may still be geologically active, both in terms of Mars quakes and in terms of volcanism. And then, of course, we come to the modern era with Perseverance and United Arab Emirates orbiter that was sent at the same time, along with a Chinese orbiter and lander, all arriving in the early 2021. Now, Curiosity, of course, back in 2012 landed on Mars. We actually observed that from the Mars Reconnaissance Orbiter high-resolution camera going in. And we've done that for several missions now, including Perseverance. Arrived at the surface in a place called Gale Crater, and it was designed to actually look for organic compounds in an ancient water-rich environment, an area where we know there are lots of sediments, probably an ancient lake bed. And so it's been exploring the floor of Gale Crater since 2012. Interesting characteristic of Curiosity was that it actually had on board a target sample of rock that was from Earth, used to calibrate some of the XRF or chemical analysis instruments that we use to analyze the composition of rocks. And so it was a piece of rock from the Earth actually on Mars now. And Perseverance has a similar calibration target, but in this case, we actually selected a couple of pieces of Martian meteorite. So these are rocks that came from Mars that are used to actually calibrate instruments that are now on Mars. So the poor rock traveled from Mars all the way to Earth and then got sent back to Mars, exported back to Mars. Of course, InSight, discussed before, very successful, observed many Mars quakes over a period of time. It's a very sensitive instrument. We've learned a lot about the interior of Mars. And of course, it's coming to the end of its useful lifetime, mainly because of dust collecting on the solar panels. Previously, we had a lot of success with the wind blowing dust off our solar panels on the Mars exploration rover, Spirit and Opportunity. But basically, the InSight mission hasn't been quite so lucky. And of course, we come to Perseverance, which just landed at the beginning of 2021, and we've been marching out across the surface of Mars. And of course, I'll talk a little bit about some of the things we've been doing in Perseverance, but one of the things that fascinates everybody is, of course, the small helicopter, which was a technology demonstration that we sent to Mars with Perseverance. And here it is after we just deployed it to the surface prior to its first flight. And down below is a view from the helicopter as it flies over the surface of Mars. This is the downward-looking camera. It has color high-resolution cameras like the one up here in the upper right. And this is essentially giving you a view of Mars as it would be like if you could fly over the surface of Mars. And it's clear that it's been a wonderfully successful technology, and that this will play a vital role in understanding not only Mars, but other planets with atmospheres in the future. To date, we've actually flown the helicopter 29 times. It's preparing for another flight shortly. Basically, we landed here. The white line is the rover traverse, we'll talk about in a second. The green line is the flight path of the helicopter. And we actually flew across this area of Badlands and landed over here where the rover is today. And altogether, it's flown about 4.5 miles, whereas the rovers travel about 7 miles over the surface of Mars. And just it's now coming up on 400 sols on the surface of Mars. So also we got a picture of Perseverance sitting out there. So one of our first images of a rover actually on the surface of Mars. Perseverance has a capability of self-driving. It's what we call auto nav. So it drives itself. So we pick a place, and here's an image, a movie of it actually driving over the surface of Mars on Sol 200 to a new location. And with that, we can actually drive upwards to 300 meters a day. So we can cover vast terrains with just letting the rover do its own thing. And it's been quite successful. And in fact, we drove a good half of the 7.5 miles that we've driven on AutoNav in just a space of a few weeks. Now, a word from your sponsor, me. The task that I do is keeping track of the geology around the rover as we drive along. And of course, geologists like to draw maps, which we color the different rock types. And so that's what you're seeing here in this panoramic view, 360 degree on the surface of Mars on Sol 66, Mars Day 66 Perseverance. And so I've mapped out different, the different rock types, soils, and aeolian features or wind-blown features, and some of the structures going on. And it turns out because we take these images in stereo, we can reproject those in orthographic or vertical perspective as it would appear if you wrapped it around the rover and laid it out on the ground. And so I can do this as we drive along and keep track of the geology and piece them together as we move along and end up with one of those long strip maps like we saw for the Mars exploration rover earlier. So this is the results of landing here and driving all the way down here and keeping track of that geology along that traverse. So this is, again, one of the first field geologic maps on the surface of Mars. And again, we're mapping, in this case, out to about 60 meters to either side of the rover as we drive along. With the mission, we actually drove along this interesting escarpment and entered this Badlands at a place that was easily accessible. Then we turned around and came all the way back using AutoNav mostly. So we did it in just the space of a couple of sols, what took us at least 200 sols initially before driving off to our main target, which was the delta of Jezero Crater. Jezero Crater is about 48 kilometers across. It was once an ancient lake, and there was a river coming into it, and at the mouth of many rivers, entering large bodies of water, oceans, lakes. You'll get a large deposit of sediment or river deltas, like the delta at the mouth of the Mississippi. And once the lake dried up, of course, the delta is exposed, and then further erosion exposed the layers to the delta. And so here's where we landed. Here's the delta, and you can see the pathway of the delta being deposited out into the former floor of the crater. And so the main goal of Perseverance was to actually look for signs of past life on Mars, so that we know that one of the best places to preserve fossils, which is essentially what we're looking for here, although microbial at best, and the signs of the former organisms in most cases. The deltas and the sediments are very finely settled out, and they bury things, and a lot of the fossils on the Earth that you are familiar with are actually recovered from places that are covered in finely deposited sediments because they preserve things. And of course, they bury them against erosion and all sorts of other events, and then are later exposed. So they're little time capsules, some deep past. And so that's one of the things we wanted to go to a delta for, because we knew that it would be likely to have the conditions that would preserve evidence for previous life on Mars. So that's what we're doing at the delta. So in order to do that, we drove around this rough area. It was so rough that it was easier to use AutoNav to drive around the rough area and come around to the delta where we're today, starting to explore it in detail. And so here's the, as we drove along in front of the delta, here's an image looking up at the front, the edge of the delta. So you can see it's beautiful river delta sediments, and the sedimentologists are having a field day, so to speak, with interpreting what some of these mean. Many of these characteristics are very similar to what you'll see in sedimentary record here on the Earth. So you can say quite a bit about what the conditions were for each of these. And of course, we're actually looking at the rocks and analyzing them so we can actually understand the chemical environment and the potential biological environment at the time. So what I'm going to do now is to take you up to where we are today. And so this is, we're sitting up on the first layers of the delta. Here's my corresponding geologic map. You can see the candy stripe of layers of different rock types that we've encountered along the way. So we're sitting up here at the base of these cliffs in this dark lavender unit. And that's where we are here. And this is the latest rock that we've actually sampled. And we just got the sample yesterday. And so there's an image of that sample, and here it is. The drill bit basically cores into the rock, pulls out a core, and this is the rock. This is what a Martian sediment looks like. And we're looking at a core that's about 1.5 centimeters across. So you're looking at individual grains of a Martian sediment deposited on the order of 3.5 billion years ago. So that brings up the real task of Perseverance, which is to collect samples for return to the Earth. And so what we've done is collected a number of samples so far. And so here's a previous example when we were out there on the crater floor. And the delta is back here in the background, by the way, illustrate how far away we are from the delta during the early days of the mission. So we drill into a rock that we already previously characterized the geologic environment very well. We know where it is. We know where it is stratigraphically, that is, in the position in the geologic column. And we drill into it, collect the sample, and it's ingested into the rover, where there's a small camera on board that takes an image of the sample in the core tube, in the sample tube, and we then seal it up. There's the sample number, and it's stored in the rover, and you won't see that sample again until it arrives on Earth in a decade or so. The samples are all collected and held on the rover, and we've collected 9 of those now. And the idea is that we go to a place and deposit all of those samples on the surface, and a later mission with a rover and a scent vehicle goes there and collects those and sends them back to the Earth. So what we're going to do where we are right now is we're going to turn around, head back down the slope, and probably collect another sample on the way. And somewhere out here in this beautifully flat, featureless area that we characterized on the way in, we'll leave the samples on the surface, and a lander with a rover will come and collect the samples from the surface and then return to a second lander, which has an ascent vehicle, and send them off of Mars, encounter an orbiting Earth return vehicle, and send them back to Earth. So it's quite a complicated process, and we're in the process of designing that architecture of that system right now, but it's still on the books, so we're still attempting to do it. And the idea is that it's probably going to be somewhere in the early 2030s when we get these samples back. Incidentally, these circles are about 100 meters across, which are our landing ellipse, our aero landing ellipse. The ellipse that I showed you for the Viking mission that we were working with were 200 by 100 kilometers across. So in the subsequent decades, we've learned how to land on Mars to such precision that we can now target an area literally 100 meters across and put a spacecraft down on it. Coming up to the end here, also at the same time, as I mentioned earlier, there was a Chinese mission to Mars. The Zhurong rover has been traversing across the surface. It looks very similar to the Spirit and Opportunity rovers, solar powered again. And it's been traversing in a place called Utopia Planitia, a fairly flat region, fairly high latitude. And there's not much information from the mission. The Chinese space program is secretive, somewhat like the early Soviet space missions were. But right now it's basically in hibernation as the later part of the Martian year arrives, when the solar power is much diminished, and hopefully will wake up and continue its journeys. The HOPE mission was an orbiter sent by the United Arab Emirates, which was their first interplanetary spacecraft, and it's been very successful. And its goal is to actually understand the climate, the atmosphere, and the environment of Mars. But it's also got cameras, so it's been taking some really lovely pictures of the global hemispheric views of Mars. On the books originally, until a few months ago, was the 2024 mission between the European Space Agency and Russia. The Europeans were building a rover, the Rosalind Franklin rover, and the Russians were building a lander, and that was going to go to Mars. But when the Russian leadership became crazy, the operations between the Europeans and the Russians became untenable, and so that lander is no longer possible. So they're basically scrambling right now about how to reconfigure for getting that mission off the ground. And also coming up somewhere in the 20, 24, 25, 26 range is a Japanese European Space Agency mission, an orbiter from the Japan, and a rover from the European Space Agency that will set down on the surface of the Martian moon Phobos and explore the surface of that for the first time. So the obvious thing that always comes up at this point is, when are humans going to Mars? And the answer has always been, basically it's 20 years from whenever you ask that question, because that's how long it's always been perceived to take to get everything set up to do so. But now we're a little bit more sophisticated. We now know that it's probably more like 30 years from whenever you start talking about really doing it. And so for a variety of reasons, for all sorts of reasons having to do with budgets and timescales and allowing for engineering difficulties, probably 2050 would be the earliest that we'll see people go to Mars. And I wouldn't be surprised if it was somewhat later than that. But that's where we are. That's where we're headed with the architecture, with the Artemis missions to the moon, trying to develop the technologies necessary to do that. So with that, I'm done. And I'll just remind you that I have a book called Missions to Mars that was published last fall. That if you want to learn more about this, about the exploration of Mars, it's a sort of a narrative history of the exploration of Mars, told from a personal perspective of my participation from essentially the very beginning of our understanding. When Mars started out looking like the view here on the right, and we ended up with the view that we now have with exploration on the surface of Mars. So with that, I'll end and take any questions.
Thank you very much, Larry. That was a great overview. We learned about a lot of things along the way. A fantastic journey you took us. I hope you see the kudos that's coming your way from the audience. Great. So let me tell everybody that the floor is now open for questions. Please use the Q&A button on your Zoom client to send us any questions you have. So let me ask, at the very beginning of your talk, you mentioned the apparently simultaneous photo taken from Earth off the Mars and from Mars off the Earth. Did you guys do something like the Cassini waveback thing that they did in 2013?
No, we didn't, but there was talk that we should do that once we got that image. But yeah, we sort of were attempting to take that image many times, getting up early in the morning and taking images pre-dawn, and so it wasn't something we could easily plan.
So it was mostly a private event for people involved
Yes, it was.
with the mission.
Yeah, and most of us didn't really understand the significance until we thought about it later.
Okay. And you mentioned the other countries, China, India, and United Arab Emirates. Can you provide us with more information on what they did and what they accomplished, or what they're doing right now?
As I said, the Chinese have been, the Chinese have been very secretive and released very little information. I understand that the Chinese did observe basically volatiles or ice with their rover, but other than that, a few panoramas. You know as much as I do about the Chinese mission. I haven't heard a lot from the UAE Hope mission, other than a few of those images, but basically I understand that it's very successful and they're studying the Mars environment, and hopefully we'll hear more about the results in the coming years as they build up the types of observations they're doing. Basically require long periods of observing different characteristics over Martian year and so on. So not a lot to add to what we've heard from the media at this point, but I'm sure we'll be hearing more.
Okay, great. Thank you. And there's some questions about H3 on Mars and the magnetosphere on Mars. Can you tell us more about that?
Yeah, the magnetosphere. Basically, there is none on modern Mars. It's all remnant magnetism, basically tied up in some of the rocks on the surface. And that's one of the things that the InSight mission went to Mars, was to understand the deep interior, the size of the core, the state of the core, and the size of the mantle which surrounds the core. Because we know on Earth that the magnetic field is generated in the core of the Earth, and it's largely the result of motions in the core. So we wanted to understand exactly what the state, the physical state, the matter state of the iron core of Mars was. And so it appears to be solid, so there's very little opportunity for the fluid motions that would generate the magnetic field that we have here on the Earth. But at one time it must have been present, because there is remnant magnetism tied up in the rocks, kind of like paleomagnetism here on the Earth. It says that there was a magnetic field early in the history, probably in the first billion years or so. But Mars is
Okay.
bathed in the cosmic radiation as a result, which is one reason why the surface is pretty sterile.
Thank you. Thank you. And then there is this question about volcanism on Mars. Can you explain apparently why volcanism starts at a certain time and then ends? Or is it just that the new volcanism covers the previous ones? How does that work?
Yeah, well, it's all of the above, basically. Why it starts and stops to begin with, is, of course, is the $64 question that many of us would like to know. But basically, the planet has a sort of cycles of melting that happen depending on a variety of factors, and different parts of the planet melt at depth at different times. So we suspect that a lot of the volcanism on Mars is tied up with the original energy contained in Mars from its formation 4 billion years ago, and that a lot of the volcanism is a result of that motions in the mantle bringing material to shallower depths, and of course the decompression results in a lot of melting, pretty much the way it does here on the Earth. The interesting thing is that we have these large volcanic areas, like the one where we have the large volcanoes like Olympus Mons. And then there's another smaller area called the Elysium volcanic field on the other side of the planet. And that's where we actually see some of the youngest volcanism, so young that we can't even count any craters whatsoever on it. So it's assumed that many of those lava flows that we see there are on the order of less than 1 million years old. So Mars is still active. Now, why it should be active there, we really don't have a clue. But that's where we also see a lot of our modern earthquakes.
Okay, so it's not right, as some call it, Mars is not a dead place then yet.
No, Mars is not a dead planet. It's definitely active. I think that's another thing that InSight seismometers taught us, is that Mars has Mars quakes on a regular basis, and fairly large ones at that. And some areas are more active than others, very much like the Earth. So it's a very active planet. Not as active as the Earth, but it's. I wouldn't be surprised if somewhere out there in the future there's a small volcanic eruption on Mars.
In the future, like 1,000 years?
Yeah, I mean, we always like to say, even here in New Mexico, we have volcanoes that happen every several thousand years, but plus or minus 1,000 years, and so we always like to say that there's going to be another eruption at some time. It's just that it doesn't have to be tomorrow.
Great. And somebody wants to know about the cyclic layerings on the delta view. What were those?
Yeah, that's the power fascination of deltas and river sediments in general. Rivers go through seasonal cycles where you'll get a lot of snow melt, or in the case of the Earth, actually seasonal storms and things. And the river flow increases, brings a lot more sediment down at some times than other times. So it'll be fairly quiescent, and you'll get these fairly thin layers. And then there'll be a spring outburst that brings down lots of sediment and dumps them. And then it'll happen again next year and the year after that. So you got these thin cycles that form. And so one of the things we hope to understand, especially by bringing back samples from the front of the delta here, is to understand, how frequent those cycles were, what was driving it, what was going on in the upstream end, causing the river in the first place. Where was it coming from? Many of us suspect that it was probably, there was lots of ice on Mars early in its history, and that periodically there was more melting of some of the ice, and so that we got these rivers flowing nearly continuously for thousands, if not millions of years, and dumping their sediments out onto these lowlands. So that was a time when it was warm enough and the water was present enough that there may have even been an opportunity for complex organic molecules to develop into life. So that's part of the purpose of bringing these samples back.
Sample return mission. Has the planning started? Do you anticipate that the Perseverance will still be operational when that happens?
Yeah, we're hoping. I mean, the planning is actually underway. The original idea was to launch in 2026, but I think we're slipped a couple of years now. So we're talking about the end of this decade, sending the landers and the rover to collect the samples on the surface of Mars, and then it'll take a while, a year or two, to get those back. So by 2033, we should have the samples back here on the Earth if all goes well. But yes, it's being planned. We're sort of approaching the end of the conceptual phase, as we call it, in the design process. It's kind of on a fast track because we want to get those samples back. So we're moving ahead, and yes, it's going to happen probably certainly within the next decade.
Great. And somebody who asked about H3 is curious. So says that the most important element is H3 for fusion energy. Do you have the capability to detect H3?
Boy, I haven't heard any of the chemical people talk about that. I'm not sure whether we could see H3. It's probably too light an element for us to really detect with the instruments. It's an elemental gas, so we wouldn't be able to see that. We can detect some fairly complex molecules with some of our instruments, but H3, I don't think so.
Okay, and now a few questions about inhibiting Mars. So first of all, given radiation levels at Mars, does it make sense to depict surface structure for a future manned exploration?
For basically, we know something about the distribution of radiation, cosmic radiation on the surface of Mars from the Mars Odyssey spacecraft, which had a gamma ray spectrometer on board. And that was the instrument used to actually measure the elemental chemistry of the whole planet globally. And so we know something about the radiation on the surface. And it turns out that most of the surface is bathed in fairly lethal radiation for humans. So we wouldn't want to be on the surface for very long. The place where the radiation is the lowest place on Mars, which is the Hellas Basin, one of the large impact basins in the southern hemisphere. And there we have the levels that approach something that you could sustain for slightly longer, but still there's no magnetic field, so it's just there's just a lot of radiation just from the cosmic rays, and the rocks themselves actually have about the same level of radiation that you would see in any volcanic area here on the Earth.
And there has been some news that maybe one place to inhibit Mars is in the lava tubes. And some people have even identified likely sites. So
Yes.
can you comment on that?
Yes. Yeah, I think that's one of the popular ideas, is that we do know that there are lava tubes on Mars. They're fairly substantial ones. They're some that we can actually see skylights or the openings where the top of the lava tube has collapsed. We have extensive maps of those around some of the large Tharsis volcanoes. And so there will be excellent places for inhabiting. And I think that will probably be the place where we'll spend a lot of our time as humans on the surface of Mars. In fact, at the end of my book, I have a little science fiction story at the end where I speculate that we have a couple of explorers who actually go out and they're looking in one of these lava tubes. And after decades of looking for life on Mars and all of these river deltas and things like that, the last place we expected to ever see life was in the volcanic area where there's no water, and we all know that volcanic areas are so lifeless. But indeed, lava tubes are actually beautiful environments for the sustaining microorganisms. And so anyway, in my science fiction story, the the astronauts explore a lava tube in the large volcano, the Tharsis region of Mars, and discover extant or existing life on the walls of the cave, much like we see on the walls of many caves in the extreme environments here on the Earth. So yes, caves are really the place to go if you're going to spend any time on Mars.
Great, thank you. And Helen from the panelist has a question.
Yes, I do. Larry, when you were showing the pictures of your geologic map, you had symbols NTCHA. What do those stand for?
Oh, those are just different designating of the different rock types. On Earth, frequently we identify formations that have nothing to do with the rock type, but it's something that we can identify over large areas, and we'll give it a name associated with some local geographic features or something. And in the case of the Perseverance landing site, although we had a characteristic lithology or a rock type in mind, we actually saw some rock types over a broad area. So we gave those rock types names, formation names. And it turns out that on that particular area on Mars, we had a small pre-existing, pre-landing quadrangle that geologists give quadrangles names based on various features within those quadrangles. But anyway, this quadrangle had a name that was basically from Canyon de Chelly, which is of course the Dene or Navajo country. And so for naming features in this early area, we chose Dene or Navajo names of typical features. And so it turns out that the particular rock type that you were seeing there with the NT on it was first observed when we did some up-close chemical analysis in a rock that was named Natani. And then in the background, there was another rock that turned out to be a beautiful late lava flow with the name of Chesh, which is the Navajo name for frog. And so anyway, that's where those letters came from. But those were actually characterized as actually known geological rock types from our analysis too. So it's just the way we keep track of things in maps.
Very, very nice. Thank you.
Thank you. And somebody wants to know more about the methane. Where is it found and what are the sources?
The methane is really a complex question. It was observed by a telescope in the early 2000s, and basically we haven't. We did send the European spacecraft, the Trace-Gas orbiter, to actually look for methane, and it just hasn't seen very much. And that we do know that there is some. We've seen it. We've confirmed it from telescopic observation. And we actually confirmed it with a single sporadic observation from the Curiosity rover. And so methane comes from a variety of sources. Of course, one is microbial, but a more common one is a non-microbial origin. There are processes operating on deep rocks on the Earth where carbon dioxide interacts with dark mafic, that is iron-rich volcanic rocks like basalt or dark lava flows deep in the ground, actually kilometers deep, that when you introduce water, which is of course moving downward through rocks from the surface, and carbon dioxide coming up from gases liberated from the mantle underneath, you basically have a chemical reaction along with the heat to do a process we call serpentinization, where you turn basically certain minerals that are common in dark volcanic rocks to a variety of other minerals that are hydrated or have fluids in their chemical makeup, one of which is serpentine. And that process liberates, as it so happens, lots of methane. So it's an inorganic process. And we suspect that Mars, having once been very wet and maybe had a lot of ice, a lot of the water soaked into the ground. That's where most of the water went, in addition to freezing out at the poles and also getting liberated to space. That water has basically moved down into the deep mantle, where the combination of the mafic, or the dark mineral rocks, and carbon dioxide has done a lot of serpentinization and a lot of methane releases. And there are certain features in the lowlands of the northern hemisphere of Mars that look like, basically places where methane is, or some sort of gas is burped to the surface, mud volcanoes, if you will. So we suspect that what happens is periodically you get a little burp of methane at sporadic places, widely dispersed over the surface of Mars. And that, you see it, methane doesn't last very long in the atmosphere. And so we detect it, and then when we try to look again, it's not there, it's evaporated, it's not being formed anymore. And it's just by chance that you happen to see it in the first place. So we'll have to be there for many years before we'll probably really determine the sources for some of the methane.
Wonderful. Thank you very much. So that was it for tonight. I would like to thank you again, Larry, very much for a great presentation, and all our panelists here for their participation. Bravo. So let me remind everybody that you could check our calendar on the website for all our upcoming events at ocastronomers.org. So thank you for joining us, and we wish you great times ahead. Everybody.